Finally, this is the last lecture for this series, and in this video we will practice the paragraph argument question with a number one question from the free response question of 2019, and you can download that package from the link below this video, or you can actually download the same thing from the College Board website directly. Start from reminding those strategies. Strategy 1 and 2 for general one, not only for this paragraph argument short answer problem, but also qualitative quantitative transition problem as well. Read entire question first and collect all the information from there, okay, with core word and important information from there. And strategy 5 and 6 specifically for the paragraph argument problem, and your first sentence is the most important, okay? So you have to write down the most important thing on your first sentence. Help your grader to understand what you are thinking directly from the reading your first sentence only, okay? And equations, graphs are and drawing, they are your weapons. You can use them and you can make a very polished paragraph length argument without the unnecessary additional description or the explanation. Now pause this video and read entire question at first, and then try to find out all the important information from there and come back. Okay, did you finish it? I choose positive charge and constant speed v0 and constant uniform field, and the effect of gravity are negligible. I choose these things as important information to solve this question. Here we're talking about the charged particle inside the field. So positive, negative, this sign is important to decide the direction of the force on that charged particle, either in the electric field or magnetic field as well. And constant speed, that's related to the magnetic field, so we can guess we may have a question related to the magnetic field on it. And it says the constant uniform field. I actually highlighted this one because while I'm reading up to here, I expect have either electric field or magnetic field. Honestly, because I had a constant speed, I expect magnetic field actually. But here it says just the uniform field. I feel like, oh, the question actually tried to hide whether that is electric field or magnetic field, or we may have both of them, okay? Or try to recognizing electric field or magnetic field itself might be a core, okay? So we can think these kind of things from this just uniform field, okay? And force of gravity is negligible, so this we can, this will be just to relate to the electric field or magnetic field without the gravitational one. Okay, so B, this is the main part for the paragraph. And what did you find out for core words from there? Yes, this is the question. You need to explain why some proton exit the region at point 1 and other exit at point 2. Use physics principle to explain your reasoning. Okay, so from here, we recognize, this question, this paragraph argument question does not asking whether yes or no, or agree or disagree, but this one is actually explain something. Okay, so you need to think about what should be your first sentence if you need to explain the situation. Okay. Before actually getting into our problem, I will briefly explain about the electric force and the magnetic force on the charged particle. Okay, I believe you guys knows these kind of things already, so I'm just comparing the core difference between these two forces. First, electric force is QE, magnetic force, so electric force, magnetic force, QVB sine theta. So electric force first. Electric force similar with gravitational force, which is mg. Okay, the force is related to the charge and electric field only, like mass and gravitational field. So if you have an object have a mass inside the gravitational field, there's no way not to have gravitational force on it. We must have a gravitational force on this object if you have object inside gravitational field. Same as here. If you have any object has a charge on it, and if you have it inside the electric field, there's no way to avoid electric force on that charge particle. Okay, the electric force is mandatory. Okay, we should have it. Okay, if the object does not move or just moving, traveling with the uniform speed, that means net force equals 0. It never guarantees there is no electric field if you have a charged particle inside the electric field, but that there must be another force to balance out with this force. That's the main thing about the electric force. If you have a charged particle inside the electric field, depending the plus minus, the direction of the force is opposite or same direction with the electric field. These kind of things is just basic. You guys have to know by now. I'm talking about if you have more core things. I'm talking about the more core things. If you have a charged particle inside the electric field, electric force on it is mandatory. Okay, it's not moving or moving with constant speed. That means there must be additional force on it to balance out, make net force equals 0. Compared to that one, magnetic force, we have a charged particle inside the magnetic field. We have two additional factors to decide magnetic force. So magnetic force is depending on charge, magnetic field, and also speed of the particle and angle between the movement of the particle and the magnetic field. So although you have a charged particle inside the magnetic field, if either velocity or sine theta equals 0, then this magnetic force could be 0. First, if velocity equals 0, so what it means, if the particle be at rest, so if you actually place a charged particle inside the magnetic field and just release it inside the magnetic field with the initial velocity equals 0, then this charged particle will not get any magnetic force on it because velocity equals 0. So here, although the object actually can moving with constant speed, if sine theta equals 0, that means if theta equal either 0 degree or 180 degree, that means when you have magnetic field, if the charged particle moving same direction with the magnetic field or opposite direction of the magnetic field, then sine theta component will be 0. Then you're not going to have magnetic force on that charged particle, although the charged particle is actually moving in the magnetic field. So it's moving but no force on it, so we will have uniform motion with a constant speed. Okay, so this is the main thing. Okay, electric force, if we have a charged particle inside the electric field, we should have it. Magnetic force, we may not have magnetic force on the charged particle, although the charged particle inside the magnetic field, if the charged particle is not moving or if the charged particle is moving with constant speed. Okay, so this is the very important concept to compare the electric force and the magnetic force on the charged particle inside the electric field and the magnetic field, and that will be core concept to answer this question as well. Okay, back to our question. Do you remember what we have to explain for that? We have electric field and magnetic field at the same region, and a proton is traveling from left to the right, and some of them is actually exit the point 1, which is the above, that's middle line, and some part is actually deflecting downward and going out to the region for the point 2. So we need to explain what actually make some proton going upward, some proton going downward. We have to explain for that one. So these kind of things for paragraph length argument, if we need to explain the difference between two, first thing you have to mention is the boundary. The boundary. Okay? Something goes up, something goes down. Then you have to explain what makes it going just flat. What makes just going neither going upward nor downward. That's the key point of this one. So we have to explain that kind of things as your first sentence. Okay? So inside the magnetic field, I'm not going to explain about the direction of the force, these kind of things with the right-hand rule, these kind of things. You should know that. And here, proton positive charge is traveling with V. And of course, we have electric force upward, magnetic force downward in this case. Okay? And we want to find out which will make some of the proton goes upward and some of them going the downward. So like I just explained, the first thing you have to find out which one actually make a boundary. So what condition make this proton traveling just go straightly. So then when you have a two force up and downward, if the particle traveling horizontally, net force must be 0, right? So electric force must be same as magnetic force. So for this case, electric force is QE and QVB sine theta, but magnetic field and the velocity are 90 degree. So sine 90 degree just 1. So this is the condition to go straight. QQ cancel. Okay? That means whatever I say from now on, charge doesn't matter. Charge is the independent one. And velocity is equal to electric field over magnetic field. This is our condition. If the speed of the charged particle is the same as the ratio of the electric field and the magnetic field in that region, that charged particle can travel horizontally without any force on it. So that means without the net force on it. Okay, so this is the condition. And if you compare this electric field, electric force and magnetic force, if velocity exactly equal to the ratio E over B, then this one will not be deflected and just go straight. But if velocity is faster than this component becomes greater than QE, so magnetic force becomes dominant. We have net force downward, so we'll deflect it downward, will go to 0.2. And if V value is slower than this value, then this force will be greater than this magnetic force. So our net force will be upward toward the same direction with the electric field, electric force, and will be deflect upward going to the region for 0.1. That's the thing that we need to explain it. To explain these kind of things, we have to explain what is the boundary first. Okay, remember that. If you need to explain the difference between two cases, first thing you have to define is what is the boundary between these two, and then greater or smaller, higher, lower, faster, slower. So those kind of things will make two different things. So this is the example answer from me. So a charged particle can travel through the region without deflection if the net force on it is 0. That is my first sentence. This means that the electric force and the magnetic force must be equal and opposite to each other, and the charged particle must travel with a certain velocity to satisfy this condition, which is QE, QVB equal, means V equal E over B. If the velocity of the charged particle is slower than V, then the upward electric force is greater than the downward magnetic force, and the particle can be deflected to the 0.1. If the velocity of the charged particle is faster than V, then the particle can be deflected to the 0.2 as the magnetic force is greater than the electric force. This is just the example. Okay, So this is not a perfect, okay? So if this is for the paper or the journal, then you have to make some kind of the notation, the cite for the equation, and you need to more specific way to explain it, but this is good enough for the answer for the exam. Okay, thank you for watching my whole video lecture over here. Okay, I hope this one is helpful for you guys, and good luck for your exam.